put a hydrogen on it first. That's going to allow it to fall off that much more easily. So we're not going to do it this way. We're not going to do the simple electron pushing. We're going to make it pick up a proton first. All right. So now what do we need to do? Put a proton on that oxygen. I'm sorry, I drew it wrong. Shame on me. Lone pair attacks the hydrogen. Lone pair attacks the hydrogen. Just making sure you're awake. Am I doing that mistake? Yeah, right. So what would happen next?
Electron would fold into the oxygen. Or would go to the oxygen.
Yeah, now we can actually give the electrons to the oxygen. And now we generate the OH group here. And a carbocation. Is that okay? All right, what's next? We went to here.
The water attacked the carbocation.
Good. We've got water floating around here because we've got H3O plus. It's in water. The product of this step is water. We got a ton of water. Water is a decent nucleophile. It attacks our carbocation. Are we happy?
We need a positive charge.
Need a positive charge on oxygen. People are going to leave that off. Okay, now what do we need to do next to get to the product?
Water will fall off.
Yeah, another water comes in. Water attacks the proton, breaking the oxygen-hydrogen bond, and voila, we're at our product. 1, 2, 3, 4-step mechanism. Now the acid derivatives are going to have a much longer mechanism. That's why we're saving it for the final, to give you just a little bit more time to absorb that material. Is that okay? Acetal, hemi-acetal stuff. David, did you have a question? Stretching?
I was a little stretching, but sure.
You called me a jerk?
No, I said sure.
Sure. I had an email recently where I had to control myself from a student.
I'm sorry about it.
Not in our class. It was trauma. Yeah, David?
So the backwards mechanism is just basically the same, but backwards.
Yeah, the arrows are going to go backwards then, right?
Sure.
To some extent. Okay, yeah.
The backwards would have like different reasons.
I'm sorry?
The backwards would need different reasons. Well, you need the deeper.
Well, we would end up saying that instead of this going to this with H3O plus, we would say this goes to this with concentrated HCl as a catalyst, no water. Because water favors hydrolysis. Concentrated acid favors formation of the acetal. Okay? So if you got water, you are gonna hydrolyze. This is dilute acid here. Concentrated acid would allow us to go from here to here. You okay with that? You have kind of a quizzical look on your face. You're not gonna swear at me again, are you? Good. I get nervous about that kind of thing. Other questions about this mechanism? Yeah.
Is either oxygen? is it
Either one.
either one?
Yeah, I mean, either one could give you the product. You could draw it either way.
If it's under a different situation though.
What do you mean if it's under a different
Like-
situation?
Say it was just one methyl attached to the oxygen instead of the whole ring.
Oh, so like this is just a methyl group over
Yeah.
here? Yeah, then the mechanism would look different, but the product would also
It
look
would still be the same?
different. Well, the product would look different though,
Okay.
right?
Yeah.
Because that might end up looking like, something like that,
Okay.
becoming that. So now we know one of these two oxygens is going to get protonated, but which one? Well, it's got to be the methoxy group, because that's the one that fell off. Okay? All right, any other questions about this mechanism?
Yeah, would you ever have a non-symmetric acetal and have to like?
Man, that'd be messy, because who knows which side would hydrolyze? I couldn't predict it. So no, I'm not going to do that to you. All right, do you want to, is that okay on mechanism of, that was a cyclic reaction mechanism, so I can nail that one? You want to do imine next while we're on the topic of mechanisms?